In the following video, we're going to examine how to use the difference of two cubes for factoring. My advice is make sure you have watched the sum of two cubes video, and it goes into more detail on how to apply the technique. I'm going to assume you have watched that video before watching this one and skip some of the steps that we have done in the past. So if you have not watched the video before, please stop and go back and then come back to this difference of two cubes. So for the difference of two cubes, difference means subtraction. And so I'm taking and finding the difference of two perfect cubes. This formula is similar in a way to the structure of the other one, except for some of the signs are different. So if I have a cubed minus b cubed, it factors into a minus b times the quantity a squared plus ab plus b squared. So again, you should probably have the first 6 perfect cubes memorized into your mind, and so that way you know when you see them that they are. When we're applying this technique, let's keep these factoring steps in mind. Always, every problem, doesn't matter what we're doing, you have to look for GCF first. Then you want to find the base numbers. And again, the base numbers are referring to find the cube roots. We say find the base numbers because if I were to just create, let's say, x to the n power, and when we know n is our exponent, that's what very easy to remember. A lot of students just know, okay, n's my exponent, but we always seem to forget what we call the x in this, and we call the x the base. So when I say find the base numbers, you're finding, the cube root of your perfect cubes. That's what we refer to as the base number. And so when you find that, you use those base numbers in the formula. So let's try a little walkthrough example and see how we do with it. So I'm going to grab the formula. It's already down here and use it. So I have x cubed minus 8. Is there a GCF between the two terms? And there's not. So now I'm going to find my cube roots. The cube root of x cubed is x, and the cube root of 8 is 2. And so x is my a, and 2 is my b. And so when I plug it in my formula, I have a minus b, so x minus 2 in the first parentheses, times, in the second parentheses, a squared. And so we just square x to get x squared, plus, we're going to do a times b. And so we're going to have 2 times x, x times 2, which is 2 times x, 2x, plus b squared. And so you're going to have 2 squared, which is just 4. And so the final factoring of the difference of cubes of x cubed minus 8 is x minus 2 times x squared plus 2x plus 4. So let's apply this technique to a little bit more complicated problems, a little bit harder cube roots than this. So again, we can see the formula on the top, and let's factor. So if I take a look, the first thing I always need to do is check for a GCF. 27y cubed and 1, there is no GCF. I know 27 is a perfect cube, and so I'm going to break it down into the cube roots, into the base numbers. And so the cube root of 27 is 3, and the cube root of y cubed is y. And for some reason, it's just hard for some students to realize, 1 is a perfect cube. The cube root of 1 is 1. And 1 is just, I want to say a perfect every number, 1's a perfect square. 1 times 1 is 1. It's a perfect cubed. 1 cubed is 1. It's a perfect fourth power. 1 to the fourth is 1. And so for some reason, it's just hard for some students to realize that 1 is a perfect cube. So I have my A and I have my B. My A is 3y and my B is 1. And so I go directly into the formula. I have A minus B, so I have 3y minus 1. In the next parentheses, I have A squared. So when I'm squaring 3y, you're going to square the 3 and square the y. So you get 9y squared. plus a times b. And so you're going to have plus, you have 3y times 1, which is just 3y, plus b squared. And so 1 squared is just going to be 1. And so the factored form of 27y cubed minus 1 is the quantity 3y minus 1 times the quantity 9y squared plus 3y plus 1. One more example like this. Does 125 and t cubed and 216 have any factors in common? The answer is no, there's not. So now I take a look, I have the difference, and I know 125 is a perfect cube. The cube root of 125 is 5. Cube root of t is t. Then I have 216, that is the perfect cube of 6. So I took the cube root of both numbers. That's going to give me my a and my b for the formula. Now I'm not going to show this process down here because if I know a, I should be able to square it just by looking at this. If I know b, I should just be able to square it by looking at this. You know, I need to take the product of them. Well, they're already written down next to each other, so I can just find the product by looking at this. So this is the key in my mind to using the formula, writing down what a is, what b is, and then when you plug them in, it's very simple. You have a minus b. Well, then I have 5t minus 6. You know, in the next parentheses, you have a squared. So square the 5 and square the t. So I get 25t squared plus a times b. Well, then a times b, 5t times 6 is 30t. Plus b squared, well, b is 6, so 6 squared is 36. So the final answer is the quantity 5t minus 6 times the quantity 25t squared plus 30t plus 36. So by identifying my a and b and writing it down, that kind of eliminates this process here. You can just look up it here and square a and square b and find their product very, very simply. So this is the difference of two cubes technique. It's very similar to the sum of two cubes technique. Just remember to identify your base numbers, which are the cube roots first, and then plug them into the formula.